Welcome to the Explainer. Today, we're diving into an absolute mechanical marvel, the human chest and lungs. We're going deep inside the body to uncover a highly sophisticated, multi-layered anatomical system that literally keeps you alive every single second of every single day, completely behind the scenes.
Okay, let's really dive into this. Think about this number for a second. 20,000. That is how many times your lungs expand and contract every single day. They're these soft, delicate, almost balloon-like organs, and they are constantly inflating and deflating right up against the hard, rigid bones of your ribcage. Honestly, by all the normal rules of mechanical friction, that continuous rubbing should cause massive tissue damage, inflammation, and eventual failure. But it doesn't. Your lungs don't just wear out. So how on earth does the body pull off this daily, friction-defying miracle?
To answer that, here is our roadmap for today's Explainer. We'll start with the body's protective compartments, move to welcome to the thorax, then the protective thoracic cage, zooming in, pleural cavities, the power of pleural fluid, and finally, when things go wrong. Let's get right into it.
Part 1. The body's protective compartments. So our first stop requires us to look at how the human body organizes its internal spaces. The body doesn't just let organs float around randomly. It compartmentalizes them into highly structured areas we call cavities. Take the largest compartment at the front of your body, the ventral cavity. The body divides this massive space into two main subdivisions. You've got the thoracic cavity up top, which houses the heart and lungs, and below that is the abdominal pelvic cavity, which holds your digestive and reproductive organs. But the true unsung hero of this setup is the structure separating them, the diaphragm. It acts as a literal muscular floor for the thoracic cavity, completely sealing off the upper half from the lower half so those upper organs can operate in their own specialized environment.
Part 2. Welcome to the thorax. Since our central mystery today is all about the lungs, we're going to zoom exclusively into that upper space. Welcome to the thoracic wing of the human body. The thoracic cavity is essentially your upper chest area. It's entirely enclosed by the rib cage and, like we just said, bound at the bottom by the diaphragm. This is the absolute command center for your cardiopulmonary system. The organs in here are doing the heavy lifting of moving blood and oxygen throughout your entire being.
And wow, is it a crowded, dynamic neighborhood in there? Inside this cavity, you have your heart, your lungs, the trachea, which is your windpipe, the esophagus delivering food to your stomach, massive blood vessels like the aorta, and incredibly complex networks of nerves. All of these structures are packed in together, and they have to coexist, expand, contract, and pulse without interfering with one another. It's a logistical masterpiece.
Now, because it's so crowded, anatomists actually subdivide the thorax even further. That central area right in the middle of your chest is called the mediastinum. You can kind of think of it as a central pillar. It securely holds the heart, the trachea, and the esophagus. By grouping these vital structures right in the center, the body brilliantly clears out the vast lateral spaces, the left and right sides of your chest, specifically to give the lungs the massive amount of room they need to properly inflate.
Part 3. The protective thoracic cage.
But you obviously can't have vital, delicate organs like the heart and lungs just sitting there unprotected. They need a fortress. And that brings us to the exterior structure guarding them, the skeletal framework of your chest. You have 12 pairs of ribs wrapping around from the thoracic vertebrae in your spine all the way to the sternum, or breastbone, in the front. But here's the absolute genius part of the design. The ribs don't attach directly bone to bone at the front. They attach via costal cartilages. This cartilage is a total game changer because it gives the rib cage flexibility. It acts like a tough cage to protect your organs from blunt trauma for sure, but thanks to that cartilage, it can actually expand its volume to let you breathe, all while serving as a sturdy anchor for muscles in your back, chest, and neck.
Part 4. Zooming in on the pleural cavities. Okay, let's keep moving inward. How does this build towards solving our friction problem? We've gone from the whole body to the chest, and now we really need to look at the exact wrapping around the lungs themselves. Within that larger thoracic house, each lung gets its own specialized, total enclosed suite called a pleural cavity. These are smaller, incredibly specific spaces that exist for one reason: to envelop the right and left lungs. They're constructed from a serous membrane called the pleura.
There is a fantastic analogy that brilliantly illustrates exactly how this membrane works. Imagine pushing your fist into a slightly underinflated balloon. Picture your fist as the lung. As you push it in, the balloon wraps around your hand, creating two distinct layers of rubber. One layer is touching your skin directly, and the other forms the outside wall, with a little pocket of air trapped between them. That is exactly how the pleural membrane surrounds your lungs.
So, translating that balloon analogy over to anatomical terms, we get these two distinct layers. The parietal pleura is like that outer balloon layer. It literally lines the hard inside walls of your rib cage and the top of the diaphragm. Then you have the visceral pleura, which is the inner balloon layer. It tightly hugs the actual tissue of your lungs. Now, they are technically one continuous membrane just folded back on itself, but this fold creates a tiny, perfectly sealed space between the lung and the chest wall.
Part 5. The power of pleural fluid.
And right in that tiny sealed space is where the magic happens. This is where we finally solve that 20,000 breath friction problem we talked about at the very beginning. I want you to take a deep breath with me right now. Go ahead. As you do, visualize this physical path moving from the outside of your chest inward. First, your chest expands. That's the hard thoracic cage. Attached to the inside of that bone is the parietal pleura. Then comes a microscopic gap filled with pleural fluid. Gliding silently on that fluid is the visceral pleura, which is physically tugging the actual lung tissue open to pull in the air.
This fluid is basically the ultimate biological shock absorber. Both layers of the pleura secrete a thin, super slippery substance called serous fluid right into that tiny cavity. When you breathe, those two membrane layers slide across one another flawlessly. No rubbing, no scraping against the ribs, just smooth, perfectly lubricated movement. And it gets better. This fluid actually creates a vacuum, a negative pressure, that essentially glues the lung to the chest wall. So when your rib cage expands, the lung is physically pulled open with it, allowing you to inhale effortlessly.
And finally, part 6, when things go wrong.
So, the crucial point here is that this entire system relies entirely on perfect balance. The fluid absolutely has to be present to lubricate, but there can't be too much of it. What happens when the body's regulation system breaks down? Well, when things go wrong, a patient might experience a condition known as pleural effusion. This is when the delicate balance of fluid secretion and absorption fails, and an abnormal amount of fluid begins to build up, pooling right there in that tiny pleural cavity between the parietal and visceral layers.
Remember how we said that cavity is supposed to be just a microscopic gap? When it fills up with excess fluid, it turns into a water balloon. That fluid takes up real, physical space inside the rigid thoracic cage. And because the ribs are solid bone and they're not going to budge, the fluid ends up pressing inward, crushing the soft lung tissue. This is exactly why patients with pleural effusion present with dyspnea, which is severe shortness of breath, because the lung literally has no room left to expand. They also present with angina, or chest pain, from the immense pressure building up inside the thorax. It perfectly highlights just how critical this tiny microscopic space is to our daily survival.
We really do take our anatomy for granted every single day. 20,000 breaths, sliding flawlessly inside a cage of bone, all powered by just a few drops of serous fluid and a paper-thin membrane. It kind of makes you wonder, as your chest effortlessly expands to take in air right now, what other silent, frictionless miracles are operating inside you at this very moment? I hope this explainer gave you a whole new appreciation for the incredible machinery of the human body. Keep wondering, keep learning, and we'll see you next time.